Alright, hello, my name is Scott Kekel, and this is the presentation for the final for the class Info 4880, the capstone. So for this presentation, I will be going over two things. One, the paper that we had to do, which we were given 5 models to look at and compare, and then from those 5 models, we had to create our own hybrid and try to eliminate most, if not all, cons. And then second, our project, our actual project is for the NRA robotics lab. I also go over that in my parts in it. So first, I'm going to start off with the waterfall model. It was created in 1970 by Winston Royce. The waterfall model is a step-by-step approach where each stage must be completed before moving on to the next. And also, you cannot visit a previous stage once you pass it. And once the project is finished, it's done. There's no going back over it or anything like that. So here we have the waterfall model. As you can see, there are 6 stages: the requirement analysis stage, the system design stage, the implementation, the testing, the deployment, and the maintenance. So going into more detail on each one, the requirement analysis stage. During this stage, all requirements for the system are to be gathered, so everyone knows what is needed to build the system. The requirements are gathered from the end user and are analyzed for their validity and possibility of incorporating them. They include such requirements as purpose, scope, perspective, functions, software attributes, user characteristics, functionalities, specifications, interface requirements, and database requirements. The system design phase. In this phase, system and software design is prepared from the requirement analysis and definition phase. All the requirements learned from the previous stage are put together to form a complete design of what a system will be. During this stage, the software and hardware that will be needed for the system is figured out. There are also logical and physical designs created to describe the system. The system design contains details and specifications of the whole system and explains how each component of the system will interact with each other. The next, we have the implementation phase. This phase is where the real code is written and compiled into operational application. During this phase, the design that was created is used. Depending on the size of the program, it is either broken down or kept whole. This is done so it is easier to integrate into the whole system later in the SDLC. After the implementation, you have the testing. This is pretty self-explanatory. The code that was created in the implementation phase is tested to make sure that it actually works according to the specifications stated. The deployment phase. After the implementation phase and testing phase, the code that is created and tested is integrated into the real system. And finally, the maintenance phase. This is the final stage of the waterfall model, and this is the process of modifying a software solution after delivery and deployment to refine output, corrective errors, and improve performance and quality. So going over some of the waterfall pros, you need to know the requirements of the system right in the beginning, since the following phases are dependent on previous stages approach and source project deadline. The amount of resources required to implement the waterfall model is lower than other methods. This model, even though it has its disadvantages, is still widely used, and that is because it is one of the first models and it is pretty simple to understand. Now, going over those cons, there's pretty much one general idea of that con, and that was I kind of touched on a little bit earlier, which is the idea of swimming upstream, going backwards. It's very difficult and expensive, if even possible, to go back to earlier stages and change things. And with no ability to go backwards, there cannot be any changes in the system design. And if you do, like I said, it will be expensive and increase cost and time of completing the software. And if you can't go back and change things, most of the time user requirements change nowadays very quickly because of the technological advancements and changes. They change quickly. So that's some pretty big cons for the waterfall model. The next model is the spiral model. The spiral model was introduced in 1986 by Barry Boehm. I think that's how you pronounce it. It is a model that incorporates the ideas of other models such as the waterfall and incremental models. However, unlike most models, the spiral is a risk-driven development or a risk-driven approach to the software process rather than a primary document-driven or code-driven process. So here I have a picture of what the spiral model looks like, or at least the one I chose to use. There are different versions. So there are 4 parts, as you can see, quadrants. The first one is determine objectives, the second one is identify and resolve risks, the third is development and test, and the fourth is plan the next iteration. So for determining objective, the baseline spiral, starting in the planning phase, requirements are gathered and risk is assessed. During the beginning of the process, there is a review of all objects for the system and requirements needed. The next step, which is identify and resolve risks. During this second stage, all the risks of this for the system are determined. What also is determined is the alternatives relative to the objectives and constraints. After that is done, a prototype is created. For the development and test stage, this stage can differ depending on what iteration of the loop the SDLC is in. If it is not on the final loop, the prototype is tested to see what modifications can be made to make it better. Before it reaches the final loop, the customer will sign off on a design. If it is the final loop, after the customer signs off on it, the prototype is developed. That means the code is for the design is written and tested. The prototype is then implemented in the system and is tested. All right, for number 4, this also depends on what iteration of the loop you are in. If a prototype is being modified, which means it's not in its last stage, it is during this stage that whoever is building the system prepares for another loop through the model. However, if it is the final loop and it meets all the requirements, it follows kind of like the waterfall approach, the basic waterfall approach. So some of the pros with the spiral model, because the model goes through the design and specifications multiple times, it's easy to change what the specifications are in case the customers need to. Which is a good thing. The waterfall doesn't do that. Like I said, the specifications can change constantly. As the model continues towards the final phase, the customer's expertise of the system grows, enabling smooth development of the product meeting clients' needs. Project monitoring is very easy and effective as it is done in each phase of the iteration. This monitoring is done by experts or by concerned people. This makes the model more transparent. On to the cons. The cost involved in this model is very high because you have many loops and you have a lot of things you got to do. Which with it being designed to go through the spiral multiple times and sometimes each iteration can be different, it makes it harder to understand this model. Looking back at the spiral model, you can see that it does look confusing, and when I was researching it, it took me a little while to comprehend this model more than others because of that, which might turn a few people off from actually using it. The only way to get out of the spiral loop is to develop a product that works, and it is to the customer's satisfaction. Remember, the customer has to sign off before you can enter the final stages. So the spiral may continue indefinitely. Risk analysis, because it's risk-driven process, risk analysis is huge. So risk analysis requires highly specific expertise, and that could hurt them in the long run. All right, for the RAD model, rapid application development is an approach to developing information systems that promises better and cheaper systems and more rapid development by having system developers and end users work together jointly in the real time to develop systems. With technology growing faster and faster every year, there was a need to have some sort of fast-based uh, system analysis and design model, especially during the 1980s and 1990s, where there was a huge jump in how fast technology started to advance. Few people wanted to wait a couple years before a new system can be created and implemented, because by that time that it's implemented, everything changes and it's already outdated and useless. Hence, the rapid part of the model, RAD has become a legitimate way to develop information systems. Right. So, the rapid application development model has four basic uh, areas. The first one is requirements planning, and second one is user design. Third is construction, and four is cutover. During the requirement planning phase, focus on user interface requirements and ignores current standards of other systems. It really just tries to get down to the nitty gritty of what it's trying to focus on this specific system and not try to worry about other ones, like current standards and stuff like that, because they want to, get pumped to start doing what they need to do to get this done. The user design phase, there's an extensive user involvement in this model. There's constantly, as you can see, the user design and the construction kind of go back and forth because they are separate but also together. This is where end users are involved from the beginning and throughout the whole process. The construction, the same people that have been involved so far generate the new code, and end users validate everything and are still part of the process. Like I said, it's back and forth. The user gives their requirements, they construct it, they got to verify it, and then final stage is the cutover stage. This is the part where there's the deliver of the new system to the customer, and planning for this must begin early in the process because they want to be quick. That's why it's rapid. This also includes testing, training, and dealing with changes, and also running new and old system together in parallel. Okay, so for the pros of the RAD model, like I said, it was fast. So because it's fast, it gets done quickly. It's usually cheaper. Also, smaller teams. There's not really big teams doing these programmings. It's tight, so it's even more savings. And because there is little time for the process, the final product is closer to current business standards. So it's higher quality in that sense. It meets what you want and it's not outdated because it's quick. Now for the cons, it's harder to deal with in bigger companies because this is based on speed. Quality of the system can be compromised. You can't really have fast and good. They don't really go together. You can, depending on how good the team is, of course. If you have great programmers and great developers, they could probably put something together fast. That's pretty decent. But if they're not, like one other con is they have to be knowledgeable, and if they're not, it could end up pretty bad. The user is involved in all stages of the model. They're constantly being used, so there could be some sort of like commitment issues, like if the user can't do it, or they don't have time for it, or they have to do other stuff. It can hinder the process. And like I said, there can't be any learning curves. You have to know what you're doing because it has to be fast paced, and it's not built for large scale projects. So that brings me to my next SDLC, which is the Agile model. The Agile model, or mostly I should say the method, was created when a bunch of people met in Utah and reached a consensus on several of the underlying principles for their various approaches. And out of that meeting, the Agile Manifesto was created. The manifesto is a long list of items. I think there's like 17 or something, maybe more, being compared to another item and saying that this one is more important than this one, and then goes to another one. This one's important to this one. So there's three basic principles that the Agile method or model follows, and that is a focus on adaptive rather than predictive methodologies. That's what Basically, things are changing, so your model has to be able to change. It can't like predict what's going to happen because you can't. It's going to change. You have to be able to ready for that. You have to be able to be adaptive. A focus on people rather than roles. This is to make sure that the people know what they're doing and that they're quality people rather than what they're supposed to be doing, I guess. And a focus on self-adaptive process. The model was based on the same rule that the best way to verify a system is to deliver working versions to the customer, then update it according to their roles. Also, because things change, this model should be adaptive in nature and be able to change when user requirements change. The Agile model takes on the idea that there should be cooperation between the developers and the customers on a daily basis throughout the project development. Because this, in my sense, I thought was a methodology rather than a certain system, there are multiple approaches taken with the Agile model in mind. Those models do have similarities, and they are all iterative models. That means the big project is broken down into smaller ones. Some of those approaches include extreme programming, crystal methodology, family, adaptive software development, and more. And here's the picture of the Agile model. As you can see, it's iterative. So you do one thing, and then you do another one, and another one. For the pros, user involvement through each phase can make sure the final model meets the right requirements. Because of the iterative approach, those requirements can be changed fairly easily, and it cares a lot about the final project. Agile supporters claim that code is the only deliverable that matters, whereas Agile opponents found that emphasis on code will lead to memory loss because the amount of documentation and modeling done is not enough. Like I said, one of the pros is that it cares a lot about the final project, a little bit more than other stuff. There's a lot of user involvement. Like the extreme programming version of Agile, there are only 2 programmers on a team, so there is a need for strong, knowledgeable people, kind of like the RAD. Looking at an iterative approach, each iteration can be complicated to design. Since it does care a lot about the final project, other parts of the process can be left behind, like I said, like documentation. And it does not scale well with higher projects. And that brings me to my last SDLC model, which is the Object-Oriented Analysis and Design. Object-Oriented Design and Analysis is like it sounds. It's very similar to object-oriented programming. This approach combines data and processes into single entities called objects. These objects are associated with real-world ideas like people, places, and things. Then, of course, like object-oriented programming, there are classes associated with those objects. That means that every class belongs to an object and has attributes of that object. And it's kind of like every class is an object and not all objects are classes, like specific. Like you have people, then you have like a specific person, like a user. All users are people, but not all people are users. The goal of this model is to make system elements more reusable, thus improving system quality and the productivity of systems analysis and design. A very popular model from this object-oriented design idea is the Rational Unified Process, also called RUP, or that's how I'm going to abbreviate it and say it. And I will use this model to kind of explain this idea. So here we have RUP. The Rational Unified Process originated by Rational Software and later by IBM. It is a heavy iterative approach that takes into account the need to accommodate change and adaptability during the development process. RUP is a iterative model, but is not like typical Agile models. Agile models take the whole process and break it down into smaller process. However, RUP has 4 main phases, and some of those phases incorporate iterative models. Those 4 phases are inception, elaboration, construction, and transition. A little bit more detail into those. Inception. In this phase, project scopes, estimated costs, risk, business care, environment, and architecture are identified. Sorry about that. Elaboration. This analysis and design are performed during this stage. Analysis detail user requirements and develop a baseline architecture. Construction, it sounds like what it is. This is where the project is built and coded. Transition takes on the typical role of the maintenance phase. In this phase, software system is tested, users tested, reworked, and deployed. That is the basic structure of the RUT model. However, like I stated, there are iterative ideals inside each of those groups. The inception phase would normally be only one iteration, while the elaboration phase may have one or two iterations and is generally considered the most crucial of the four phases. Because that's where a lot of the analysis design takes place. That's where the chunk of system design is done. Because user input is taken into consideration in the construction phase, it could have multiple iterations. Finally, the transition phase just keeps going until the project is finished, because that is where you deploy the system and test it. Going on to the pros, it supports changing requirements to meet its desired software. Improved management, high quality software that fulfills users' requirements is delivered regularly and on time. Because of the iterative approach in the elaboration stage, where most of the time is spent, it makes sure that the right requirements are met. The team, these are the cons. The team members need to be experts in their field, again, like the past couple models, to develop the software under this methodology. Also, it needs constant feedback from customers, which, like I stated earlier, customer commitment could not always be a good thing. It can cause problems, and it's fairly complicated to understand, like the spiral model. And that brings me to my hybrid model. So basically what I looked at was kind of where all the models were good and where all the models were bad. Like you have the waterfall model, you can't go back, so you have to have some sort of iterative approach. You have to have somewhere where it could loop back into changing requirements. That's what I got from the water model. From the spiral model, the risk is good, so you want some sort of risk analysis or assessment, but you want to simplify it and don't have so many loops to where you may never get out of it. For the rapid, it's quick, it's good, except for you need strong knowledge, and it's maybe a little bit too quick sometimes. For the agile, let me go back to that. Kind of the same thing, you have to have knowledgeable people, and you have to go look out for that. And then finally, the object-oriented, it's kind of the same yet again. Customer feedback was also some of that for the agile and object-oriented and rad. You want user feedback, but you don't want them to be so involved that they might just say, you know what, this is ridiculous. I have other stuff to do. You got to keep them involved, but not too much. You got to have a risk analysis, but not too much. So that brings me to my design. It's kind of, after I put this together, I thought about it, and I'm like, well, this kind of looks like rad. It really does. You got your analysis, your designs, and your users, and then the end. And it's kind of similar to rad more than any other one, I will admit that. Which is why I'm calling it the Class 1 rad. Because, Class 1 Rapid's slower than most. Anyways. It is a little different, though. So going through it, first you have the analysis phase where you sit down, you do all the analysis like the other typical models. Where you first gather end user input and analyze all that, and then the purpose, the scope, the perspective, and all of that. And then right after that, you do the risk assessment. Like I said, that was good for the spiral model, but you can't have too much of it because it would complicate things. But you can't have it at all because then you run the risk. of not having something good. So that is when the risk assessment comes into place. And after that, if there's no changes made or if there are changes made, you get user feedback one more time. And then comes the iterative and the kind of the broken down parts, where this is where you break down the big project into smaller projects where people will design it. But everybody going into this will know exactly what they're supposed to do because they've all been part of the analysis design phase rather than breaking that up in each one. They're part of it as a whole, and then they can design it right then and there. After they design it, they go back to the user, make sure it's good to go, and like this is how it's like rad. This phase should be quick, but not too quick to where it starts to run the risk of not being too good, and also kind of a little bit slower than rad so that it doesn't the user knowledge there if there needs to be some sort of learning curve, it can be, but not so slow that by the time they're done all the technology that they just built is outdated. After that, they go back, like I said, they go back to the user feedback and they sign off on it or don't sign off on it. And if they don't, they go back through this design phase, do it all over again. That's where you want to be quick, and you want to make sure you have the requirements beforehand. And you want to do the risk analysis so that everything is set in place so it reduces the risk of the user changing things up and not liking it, so that it eliminates as many loops as it can. And after the user gives its feedback and he okays it, and then it goes into the final phases, which is the testing, the deployment, and maintenance, which is pretty self-explanatory. Those phases should be fairly quickly, because most of the testing and deployment will be thought out in the analysis phase, like how they're going to test it and how they're going to deploy it. That's why everybody knows what you're doing, and it smooths transitions throughout. So that's my hybrid model. And that ends the part about my paper. And the next part is about our virtual lab, our group project that we did, which will be the next couple of slides. So robots have been around for a while now, but they have always been evolving and getting better and better. Just imagine what robots are capable of now and what they can be capable of with more research. Robots have the potential to do anything from helping with disabled fighting in battle, which could be a bad thing depending on your philosophy, or potential to help people with disabilities on their daily activities, or any workers, any hazard workers. They can improve the quality of life, the daily quality of life. And this is where the NRI proposal steps into place. Our final project for the capstone course was to come up with a proposal for the National Robotics Initiative 2.0, ubiquitous collaborative robotics, or robots. The goal for the National Robotics Initiative is to support fundamental research that will accelerate the development and use of robots in the United States that work beside and cooperatively with people. Since this is the 2.0 version, there was already a original version, and so they are a little obviously different. The 2.0 version is meant to take the idea of the first one and add the idea of scalability. That is, the NRI proposal is to take on the challenge of figuring out how to have many robots and many humans working together. Also, they would like to figure out how to have robots complete a variety of tasks in a variety of situations. Kind of the scalability, it can change in certain situations. Because with less interaction with changing the robot with every situation, that would allow them to easily scale them for more operations. Another goal for this NRI proposal is to have a great amount of collaboration between academic, industry, nonprofit, and other organizations. To summarize, the main ideas that this proposal wants to deal with is achieving their version of ubiquitous collaboration robots, where robots are as common as cars. Also, the idea of co-team robots, where multiple people will collaborate with multiple robots. So what do they want? I kind of touched on it, but more specifically, the NRI is really looking for these proposals to be able to demonstrate that they have the capability to have robots that can easily customizable and personal. Like they stated, they want it to be as common as cars, and cars are customizable and personalizable. That's the word. And facilities should be able to accommodate a wide range of variety of tasks. These robots should be designated to operate in real-world environments. These facilities should also lower the barrier to entry in robotics research. That means that these research areas should be easily accessible and used by large research communities. Also, these facilities should bring to the forefront social, economic, ethical, and legal issues. All organizations wishing to gain funding should be able to accomplish these goals. For this proposal, there are these ideas of research themes. Some of these ideas were already touched on, but there are 6 themes in total. These themes include collaboration, which is the idea of multiple robots and multiple people working together and exchange data and learn from each other. And that data interaction, which is to incorporate some natural level of interaction for easier use. Scalability, make sure robots can easily be customized and personalized. Physical embodiment, make sure the robot can perform a multitude of tasks in a real-world environment. Lowering barriers, develop easy-to-use software and hardware. Develop an ability to facilitate shareable physical testbeds. And finally, societal impact, which is the investigate social, legal, and ethical impacts of robots. So there are 2 classes that they kind of put together, and each class gets a different reward amount, and they have different criteria, of course. The 2 classes are the Foundation with the range of $350,000 to $750,000, and Integrative with the range of $500,000 to $1.5 million. Now, foundational focuses on research into technologies that directly support one or more of these themes. This class should lead to transformative approaches that address scientific or technological gaps that currently limit the development, use, or acceptance of robots. While the integrative focuses on one or more of these themes as well, however, this class deals with integration of technology rather than how that technology will transform things. This must include the evaluation of physical robots in the real-world environment, and these projects would have a longer-term vision. So now that comes into now our part comes into play. The class was given a project to submit a proposal for potential building and get funding from the NRA. We were divided up into multiple teams. Those teams are project management, social media, security, web development, and database. Project management, as it sounds, was in charge of managing everything and putting all the documents together to form a proposal. They had to put together a project description and overview, detail, work breakdown structure, Gantt chart, and project budget. Social media had to put together a system to support group collaborations, comments, announcements, posting of photos, videos, and having some kind of advertising. Also provide means to give feedback and recommendations. Finally, they have to be able to track how any active and inactive users there are. The security team is obviously in charge of putting together multiple security plans. Those plans include the electronic and physical authentication, disaster recovery, data and information protection, physical resource protection, identity and privacy protection, and web server security. The web development team was in charge of handling the website and multiple things that it has to include in the website. There will need to be some sort of lab usage request. The request will give the users the ability to choose different robots and environments. The website should also allow the user to schedule a time to use the lab. They should be able to securely get login credentials. People should also be able to access the lab via webcams through the website, provide some sort of means of communication. Also, the website should incorporate some sort of database. Finally is the database team. The team was in charge of setting up a database that the website would use. A couple of tables that the database had to have was a user's table, a lab schedules, resource availability, login credentials, social media users, and lab requests. Forms had to be used to get user information, and that data would be then stored into those tables. This would be done through SQL queries. So there was multiple teams for this project. I had a couple myself. I was put in a couple, not all of them. We could come up with our own teams, but we decided to stick with the sheet we were given for the project. I was assigned to three groups: the security, web development, and database. However, due to a fender bender I got when they were talking about the web development, I really wasn't part of the web development part, but we could choose our own team, so I didn't think it really would matter. There was a lot of people in it, and they did great work, I think. And so I really was just in the security and the database team. So for the security, we had to come up with a bunch of security plans, and these are the plans. Electronic access, we use Tyco Integrated Security. Tyco uses a range of electronic access control devices, locks, and systems with management tools to help you control devices, locks, and systems. That's doubled. To help you control access to your office facilities and operations. In addition, Tyco offers complete support in the layout, installation, and assignment of the systems. Beyond the security portion, the electronic facility access control technology delivers valuable business intelligence, allowing the owner of the company to know who is entering and leaving the facility, at what time, and the duration of their visit, all while keeping record of the activity relating to facility access. So, of course, with that, the ideas of it was we had to authenticate the access, and there would be certain levels of authorization and access to certain areas. Which brings in permissions. We had 3 levels of permission. Level 1 permission was access to the main lab, printing ability, and permission to view lab resources. And these were, of course, the people that were going to be working inside the lab, not like the people on the other end of the website that were like testing their stuff. Level 2 permissions includes all level 1 and also access to testing and coding room, permissions to create lab resources, and update policies. Level 3 permissions required a secret security clearance, and all level 2 and level 1 permissions. They had access to server room, access to financial data and personal files, permission to edit and delete files, access to physical resources. They could add or remove users. They could request equipment and resources. This is obviously the highest, and only a few people would have that kind of access. Very few. Next, I have the disaster recovery plan. I'm sorry, my list there isn't really the same here, but the next part is disaster recovery plan. Disaster recovery plan will be put in place to ensure the recovery or maintenance of vital technology, organizations, and systems following a natural or human-induced disaster. The policy will apply to everyone that has access to the virtual lab. And it will also ensure the recovery time for such disasters and how to recover information that was damaged or lost. The requirements of this policy shall be implemented by everyone who has access to the virtual lab, and failure to comply with the policy will result in their access to the lab being revoked. So if there's a disaster, the first thing to do is assess damage. Once damage has been assessed, personnel should document all damage and loss of equipment. And then they should begin recovering data as soon as possible so that they get business up and running again. All physical equipment in the lab must be insured. A lab should be properly insulated to protect against abnormal temperatures. There should be a sealed room which would allow you to use a gas-based fire suppression system such as the FM200 from Ceasefire. Ceasefire FM200, when detectors sense a rise in temperature above normal levels, particles of smoke, or a change in quality of air, they alert the control panel and they emit this gas that's can be used. That's safer technology. Sprinkler systems must be put in place according to local fire codes. All emergency power off functions should be put in place. If there's a fire, the EPO will drop all power to the room immediately. Although this will cause some data damage, it is less than that will be caused by a fire. If the fire is electrical in nature, this may stop it entirely. If all power is dropped to the equipment, less damage will be done than if and when the sprinkler system turns on. Next is the Data and Information Protection Plan. So a data and information protection plan will be put in place to protect data from being lost, corrupted, compromised, or stolen through hardware failure, human error, hacking, and malware. This policy recognizes that the backup and maintenance of data for the virtual lab is critical. The viability of the sensitive research data experiments, login credentials, expanse of equipment, the handling of chemicals in electronics, web servers, and webcams in a physical space that happen in this lab. In addition, the objectives of this lab are to prevent loss of data in the case of accidental deletion, corruption of data, system failure, and or disaster. The requirement of this policy shall be implemented by everyone who has access to the lab, and failure to comply with the policy will result in your access being revoked. So all data should be backed up through Expedient Data Center in Cleveland, Ohio. Data will be backed up on a regular basis, either daily or weekly, depending on the type of data and requirements. Backup data will be verified monthly. All data should be encrypted with at least an AES standard, which is the typical standard now. Depending on the information, there will be levels of authorization access to that information. Access logs will be kept for all data files and servers. Missing a page, that's why. All right, for the Physical Resource Protection Plan, the purpose of the Physical Resource Protection Plan is to ensure that anyone that has access to the equipment in the lab are prepared in case of stolen or damaged property. The persons who have access to the equipment will need to understand the steps in place to make sure the equipment is properly protected. So all physical equipment will be kept in the locked room. All equipment will be labeled with some sort of code, either a barcode or QR code. That way it can be easily managed and easily entered in databases or checked out. Only authorized people will have access to it. All access to the room will be logged, so we know who's in there, how long they're in there, what they're getting, which every time something is taken out of the room, that equipment must be logged. The log should contain who logged it out, what they're using it for, and how long they will have it. Next is the Identity and Privacy Protection Plan. The purpose of this plan is to identify the individuals that do the experiment in the virtual lab and protect them from any outsiders trying to gain access to any sensitive information. In addition, this plan is to intend to help employees determine what information can be disclosed to people that do not have access to the lab. Some of the objectives of this plan are to ensure information that is either stored or shared by any means, which includes electronic information, information on paper, and information shared orally or visibly, on determining what is secure. And to prevent people that do not have access to the lab, do not access sensitive information by restricting computer use. That way, the amount of risk is minimized. The requirements of the policy shall be implemented by everybody who has access to the virtual lab, and failure to comply with the policy will result in their access being revoked. So some ideas for this is all participating organizations and people will be kept classified unless that organization or person decides otherwise. We keep the data protected from all people, and all data will be encrypted with AES standards. When connecting the virtual lab via camera or any other means, that connection should be secured so no one can look through what is happening. The idea is that all connections should be through VPNs so that we create a secure tunnel. When there's an experiment, there should be a defined list on who is involved, especially pertaining to the people that are physically in the lab assisting the participants conducting their experiments. There should be a trusted relationship between the people in the lab and the organizations on the other end. Oh, there's the paper. For the physical location access, like I said, we're going to use Tyco Integrated Security. And then we're going to be keycards access to certain rooms like the equipment room and lab room. Alarm must be activated when no one is in the building. Only a handful of people should have keys to the building. There should be a camera located near all entrances inside the equipment room. Logs should be kept on who accesses what, when, where, why. What are the daytime access? That should be set in one of the off hours. For the web server, we chose a HP Store Easy 1450 16 terabyte SATA storage for $6,500. And that is the security portion. And finally, the database. None of us were really some of us were security concentrated, web concentrated. I don't even know if anybody was web concentrated, social media concentrated, but not many. I don't think anybody was database concentrated. So this one was a little tough for us because we had limited knowledge of it. We all took a basic database class, but that was years ago. And I think two of us took e-commerce, which integrated database, but it wasn't exactly the prime focus. But I did definitely use something off that. So for the tables, we used Oracle database, and for the tables, we had a couple: the users tables, the lab schedule, the social media, the employee, the lab requests, and then we had 3 data tables: the environmental resources, the robotics, and the sensors. The data tables just would contain a list of all resources out there that they are with some ID. The lab request, when I was taking the e-commerce class, I kind of took that idea where each lab request would have certain fields, like they all have ID. Users have IDs, names, passwords, and the passwords are encrypted. The lab schedule containing certain data. All right, sorry about that. I had to grab my paper for the actual database. Okay, so our users table have a username, password, full name, work or school affiliation, position, occupation, and email. And all password or sensitive information will be encrypted in these databases. The lab schedule included the user ID, the lab request ID, the time, and the date of request. For the lab request, it has it's connected with the user ID, lab request, environmental ID, so it's connected to another table, and then it has the water tank that you chose if you chose one, and then all the certain specifications for the water tank, like pH level and stuff. The sensors that you chose, the robot ID, the employee ID, the resource ID, those are all connected to other tables. The social media would have your Facebook, your Reddit, and your YouTube. Employee records for the employees, obviously. The name, the address, the contact info, the employee number, and the unique ID swipe card. And then you have the robots and the environmental resources, which are data tables, which will contain all the robots that there are and all the environmental that they are, so that they can connect to other tables. So that's pretty much this wraps up for my presentation. I talked about my paper and my hybrid model, and then I talked about the NRI and then my contribution to that project, which is security in the database. And that's pretty much it.